Good day, Dr. Ashu. Today we like to present about the system modeling simulation for Nombakaba company. For the presentation today, it's all about current situation that occur in the factory right now. First of all, the sources at here means that the lorry unloading the component in bulk on a pallet at the warehouse. Therefore, the AGV in seat of forklift will transfer the pallet to the buffer, and the buffer represents a temporary storage to awaiting for detach into the box. Therefore, the assembly table will detach the component into the box and transfer it again, and we see at the buffer here have buffer for pallet and box containing components. The worker will transfer the box to the rack storage to awaiting station worker to correct for it. The station worker will exchange the empty box with new box and bring it back to the buffer and continue with the assembly process. That is all from me and pass it to my team member for further detailed station explanation.
Now I would like to present the current progress of our assembly line simulation. To begin with the material flow, we have designed the sources for both line A and line B to act as arrival points for bulk materials coming from the main warehouse and supermarkets. Rather than having an infinite supply, for line A, we implemented a specific gating logic where parts are first transferred into component buffers at each station, and we have assigned a predefined capacity to these buffers to simulate real-world storage limits. The logic links these buffers directly to the assembly station. For example, for this line A, we have four assembly stations, which is A1, A2, A3, and A4. And for each assembly station, we will pull the specific required parts from each buffer, process them, and assemble the new product. The assembled new product will be transferred into the specific drain for that particular product. Okay, moving on to line B, the workflow follows a similar logic to line A, but with two key architectural differences. Firstly, we have configured station B1 and B4 to operate as a single combined workstation, meaning the tasks for both stages are handled within one location. Secondly, because this line produces multiple product variants, we implemented a flow control object at the end of the line. This system reads the name of each finished product and automatically sorts it to its respective drains. Okay, for the B1 and B4 station, we have six different uh, products. So we have six different drains. Okay. For station B2 and B3, the logic remains consistent with the standard flow used in line A. Okay, now I will simulate one more time in 3D model to show you how our station process the task. Okay. This is the line A stations. Okay. That's all for our simulation. Then currently, while the core material flow is functional, the model is not yet fully complete. We have not yet implemented the worker pool, so the assembly line is currently running without labor constraints. So additionally, there are a few specific stations that haven't been fully constructed yet, as we are facing some complex technical issues regarding their logic and connectivity. So we have identified these problems earlier and we require further assistance and consultation from Dr. Azo to ensure they are modeled accordingly. That's all from us. Thank you.